Hey guys, how's it going? This is our first video on chapter 13. So remember, these can only be about 15 minutes. So it's probably going to take a couple videos to get through 13.1 and 13.2. So just be prepared. You're going to have to watch a couple videos. So I hope you're having a good spring break, or you had a good spring break. And let's get started. So chapter 13 is all about things called sequences and series. So we're going to talk about a sequence and a series first. 13.1 is general information. And then 13.2, 13.3, we get some specific types of sequences and series. So let's talk about what a sequence is. A sequence is basically just a list of numbers. They typically will follow some pattern. And in fact, later on, again, when we do the next two sections, that pattern they follow will be very, very evident. But right now, it's just gonna be kind of general information. Here's an example: 1, 3, 5, and 7. You can see the pattern is they're adding 2 every time. So again, not the most exciting pattern. Notice that in a sequence, every term is separated by a comma, right? So we could keep going with this. We could go 9, 11, and then dot, dot, dot. That dot, dot, dot means it's going on forever. Each one of these numbers in a sequence is called a term of that sequence. And we denote terms using subscripts, a sub n. So a sub n is the nth term. So if I go look at my sequence from above, the first term would be 1 in that sequence. The second term would be 3. And I don't know what the nth term is. We would just call that a sub n. It's somewhere down the line. 5 would be the third term. So we would call that a sub 3. So each term gets its own little subscript. The first thing they're going to want you to be able to do is, if they give you a formula, they're going to want you to be able to write down the terms. So they're giving you this formula. They're calling it a sub n equals n minus 1 divided by n. And they want us to do the first 6 terms. So a sub 1, all we do is plug the n in. That's going to be 1 minus 1 over 1, 0 over 1, or 0. So the first term in my sequence is 0. A sub 2, 2 minus 1 divided by 2, 1/2. The third term, 3 minus 1 divided by 3, 2/3. The fourth term, 4 minus 1 divided by 4, 3/4. The fifth term, 5 minus 1 divided by 5, 4/5. And you probably see the pattern already. The next term is going to be 5/6. So there are the first 6 terms in that. They also want you to graph it. So if you look at the next page, they went ahead and graphed it for you. Right there, those are the terms we just found. This is actually a decreasing function, right? So it's actually getting lower. Well, it's not getting lower. The difference between the values is getting smaller, right? So we could connect those dots. Almost looks like root x a little bit. So that's that example. Now, I was going to have you try one, but for some reason I gave you the exact same formula. That was kind of silly, right? So I'm going to give you a different formula. Let's see, what formula did I decide to give you? So instead of doing this, I would like you to try a sub n equals n squared minus 1 divided by n. All right. So why don't you come up with the first 6 terms? I'll actually put the answer key up where I did it, and you can check your answers versus mine. So you're going to do the first 6 terms of that, just like I did before. And then you're going to go back and check your answers just like we were in class. So you can pause the video if you want and do that, or you can just keep watching it and do it later on your own terms. That's cool. I'm going to keep going. So in this section, we have a new math symbol that we need to know, something called factorial. All right, factorial looks like an exclamation point, right? So in factorial, that's how you read that mathematically. You're going to be using factorial a lot. You probably saw it in your college algebra. I don't know if you remember something called the binomial distribution, but you saw it then. Here's one formula for n factorial. N factorial is n times n minus 1 factorial. There's a better formula in my opinion. It's going to be n times n minus 1 times n minus 2, and you're going to keep doing that until you run out of n's to multiply by. So we can keep expanding the factorial. Let's do a couple of them. So if somebody says, what's 8 factorial? That's going to be 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1. And as soon as you get to 1, you stop. You don't go to negative numbers. 4 factorial will be 4 times 3 times 2 times 1. By the way, these should be numbers if you do them correctly. The first one is going to be 40,320, like if you multiply all those together. And the second one's going to be 24. You'll see why we need factorial later in the chapter. So factorials will become really important later in the chapter. All right. So the next thing we need to be able to do is something called a series. So if we take a sequence of numbers and we add them up, that's called a series. So if you add up a sequence, it's called a series. We're going to notate it in a couple different ways. We're either going to notate it as a series, meaning actual adding them up, or we're going to use something called summation notation. So that's what we're going to talk about. Summation notation is a shorthand notation to talk about a series. So again, a series is a sequence added up. Notice there's no longer the comma signs, there's now adding signs. You could actually add the series up. You just add the numbers up. But to make it a little easier, we actually use something called summation notation. So let's take a second and talk about that. That's what this symbol means. This symbol means sum. The bottom is where you start. That's the first number you plug in to sum up. And the n is where you stop. So again, notice the first term to the nth term. Remember that subscript is the number of terms. So the first thing they're going to want you to be able to do is expand a summation notation. So we're actually going to expand this out. So I put 1 in. Well, 1 divided by 1 is 1. Plus, again, we're summing it because this is not a sequence of numbers. This is a series of numbers. Now I'm going to plug 2 in. If I plug 2 in, I get 1/2. Plus, if I plug 3 in, I get 1/3. I'm going to put dot, 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 which implies there's a bunch of terms below it, or between these two. And my final term will be 1 over n. This is the sum expanded out. This is the sum written in summation notation. All right. They're also going to want you to be able to evaluate, meaning actually find the number of a sum. And they're going to want you to be able to write it in summation notation. So let's take the sum and turn it back into summation notation. So if I look at this sum here, first thing I had to do is figure out the pattern. Well, this is 1 to the second power, 2 to the second power, 3 to the second power. So to me, it looks like each term is n squared, right? If I plug 1 in, 2 in, 3 in, all the way. And it looks like I have 9 terms. So I would write this summation notation, as k goes from 1 to 9 n squared. Mathematically, these are equivalent statements. Those say the same thing mathematically. One is the sum, one is the sum written in summation notation. That's all it is. For the second example, they kind of cheated here. They're actually giving you the formula. So this is the summation as k goes from 1. Notice we don't know where it stops this time, so we're going to leave it as n. And then here's the formula. And again, if you plug 1 in, right, you can see you get 1. If you plug 2 in, you get 2, etc. So sometimes they're going to want you to actually evaluate a summation, and there's some nice shortcuts to know. Shortcut number 1, if there's a number inside the summation, you can actually pull the number to the front. So if there's a constant inside the summation, it can get pulled to the front. Formula number 2, if you have a addition inside of a sum, you can expand it to the sum, the addition of sums. The same thing works with subtraction. And again, these are very similar types of information. It's in fact some of the same things repeated. It actually turns out if you sum up a constant number, all you do is take that constant number times n. If you sum up a single term, if it's just k, 1 plus 2 plus 3 plus blah, 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 there's an actual nice formula. This will actually be the value of the sum. If you sum up k squared, you can use this formula to evaluate it. And if you sum up k cubed, you can use this formula. Again, I know these formulas look really ugly. Don't freak out. They're really not bad. In fact, I wrote, again, what they all do for you. So you can read that again if you want to. Let's do a couple examples of what they're going to want you to do. So problem A. They want us to evaluate if k goes from 1 to 5, 3 times k. Now we could do this by hand. You could plug 1 in, and then 2 in, and then 3 in, and then 4 in, and then 5 in, and you could add those up, which I'll show you that in just a second. Or we can actually use one of these formulas. So I don't know if you remember, it said if there's a constant inside, you can actually bring that to the front of the sum. And then I can actually use this formula up here, because this is what I have here, the summation of k. So this becomes 3 times, if it's k, it's n times n plus 1 over 2. And for this problem, my n value is 5. So this becomes 3 times 5 times 6 over 2, which becomes 3 times 15, which becomes 45. So if I did this correctly, this sum should add up to 45. Let's do it manually and see. So if I plug 1 in, I get 3. If I plug 2 in, I get 6. If I plug 3 in, I get 9. If I plug 4 in, I get 12. And if I plug 5 in, I get 15. And again, if we did it correctly, those numbers should add up to 45. Let's check. 3 plus 6 plus 9 plus 12 plus 15. Just kidding, I added something in wrong. 3 plus 6 plus 9 plus 12 plus 15 is in fact 45. So again, you could do it either way. It doesn't matter which way you do it. You can use the sum or not. Let's do one more. Let's do B. I need another piece of paper though because I ran out of space. And then I'm going to let you try C and D. Once again, I'll do the answers and then I'll put the answers on the webpage. So problem B. Summation as k goes from 1 to 10, k cubed plus 1. So the first thing I'm going to use is that I can take the sum of addition and break it up into the addition of sums. So I'm breaking up my one sum into two sums. This one's actually this one. This is just the sum of a constant. So this actually just becomes 10 times 1. And this is the other formula. This is the k cubed formula. This is right up here. So this becomes n times n plus 1 over 2 to the second power. 10 times 11 divided by 2 to the second power plus 10. And when you multiply and do all this stuff, you get 3,035. You don't believe me? Add up all 10 of them, you'll get 3,035. If you feel like it, knock yourself out. I'm not going to because I feel confident in math. So again, why don't you try C and D? And again, I'll post the answers when I finish up this video. I'm gonna stop it right here because I'm at 13 minutes and then we'll do 13.2.